Hey guys, Gary Matula here with another eMathInstruction Common Core Algebra 1 video. Today, we're going to be working on Unit 8, Lesson 4, Completing the Square. But before we do, I just want to mention a couple things. Today's worksheet and all the worksheets and homework assignments can be found on eMathInstruction.com or by clicking the link down below. Also, on the top of a lot of worksheets, there's a QR code. This QR code will link you directly to the YouTube video that goes along with it. All right, now we can begin. All right, so I mentioned that today we're going to be working with completing the square. But before we learn how to complete the square, I want to talk to you guys about why we complete the square in the first place. So the first thing we have to realize is that a quadratic function has a bunch of different forms, but the most general form looks like this: x squared plus bx plus c. So I know there could be an a term here, any term here, but we're going to deal with cases that only have a 1 or no term in front of the x squared. All right, so a quadratic function can be written in this form, but a lot of the time it's going to be more useful to write it in shifted or vertex form. And remember, you learned yesterday that shifted or vertex form looks something like this, or more generally speaking, y is equal to x minus h squared plus k. And remember, if we write it in this form, or if it's written in this form, we can find out a lot of information. We can find out, right by just looking at the equation, the vertex or the turning point. We can find the vertex or the turning point. Remember, the vertex or the turning point are just h comma k. It's okay. So if we look at this example, part A says give the coordinates of the turning point. Well, looking at this question, h is just going to be my 3, and k is going to be the 2. So the turning point is just going to be 3, 2. Now the turning point, remember, is the lowest point in my parabola, which gives me a lot of information, and I can find a lot of stuff by just thinking about it. So if we look at part B, it says to determine the range by drawing a rough sketch. Well, a rough sketch, or a rough idea of what it's going to look like, is going to tell me a lot. So let's look at a rough sketch really quick. Let's just draw it out. So here are my axes. And now if I plot my turning point, right, I'll plot that point, 1, 2, 3, 1, 2. Here's my vertex or turning point. I can also draw a rough sketch of the entire graph, right? So remember, the term out here is positive, which means my parabola is opening upwards. So it's going to look something like that. And now I can determine the range. Well, remember, the range is just a set of all y values. Right? So we're talking about all the values off of the y in the y direction. Well, my smallest y value is 2, and I don't have a largest y value, so I'm going to call that infinity. So if I want to talk about the range or all of the y values, I'm going to say it's everything between 2 and including 2, and then up to infinity. I can also write this in inequality form, right? You guys have seen this. This is just saying the same thing. 2 is smaller than y, smaller than or equal to y is bigger than or equal to 2, and it has to be less than infinity. Either one of those forms work. All right, so just to recap, the reason I'm going to be completing the square is because I want to make my function look like this. Now, let's see how I can do that. So why don't you guys take a couple seconds, copy this down if you haven't already, and I'm going to erase it. So, exercise 2 says, write each of the following as an equivalent trinomial. So each one of these are perfect squares, right? Each perfect square trinomials. And I'm going to rewrite each one of these as a trinomial. What I'm really doing is I'm working backwards from the completing the square method. And we'll see that in a second. So all we're doing right now is we're distributing. So I'll show you the first one. I'm going to rewrite x plus 5 squared as x plus 5 times x plus 5. And I'm going to write it as a trinomial, or 3 terms. So I'll distribute. I'm going to distribute the whole x plus 5 onto each one of those 2 terms, which gives me x plus 5 times x plus x plus 5 times 5. And then I'm going to distribute again. Remember, this is called double distributing. And I'll get x squared plus 5x plus 5x plus 25. And then combining my like terms, I get x squared plus 10x plus 25. All right, and I'm done. I wrote it as a trinomial. All right, so let's try one with a negative sign now. So I'll rewrite this one as x minus 3 times x minus 3. And this time, instead of double distributing, I'll distribute each term individually. So if I do that, I'll get x times x, or x squared, x times negative 3, or negative 3x, negative 3 times x, or negative 3x, and negative 3 times negative 3, or positive 9. Combining my like terms, I get x squared minus 6x plus 9. All right. And part C. Part C says x plus 4 squared. So why don't you guys pause the video and distribute this for me, either way you want. And then I'll do it with you in a second. All right. So let's do it together now. So if I wrote this as x plus 4 times x plus 4, I can use either way. I'm going to use this method though. So I'll distribute each term individually. So I get x squared, or x times x, which gives me x squared. X times 4, which gives me plus 4x. 4 times x, which gives me plus 4x. And 4 times 4, which gives me plus 16. Combining like terms, I get x squared plus 8x plus 16. That's 8x. And I'm done. All right. Well, now, exercise 3 says, given each trinomial in exercise 2 of the form x squared plus bx plus c. So each one of these, x squared plus bx plus c. X squared, this one's minus bx plus c. But given each one of these, what is true about the relationship between b and c? What's true about this term and this term? It's true about these, the b and the c terms. It might not look like there is, but there's actually a very important relationship. The relationship is this. If we take our b term, divide it by 2, and then square it, we're always going to get our c term. That's our relationship. So let's check it out in exercise A, because it tells me to illustrate. So let's look back at exercise number 2. Let's look at A and show it. So if I take my b term, 10, divide it by 2, and then square it, I should get my c term. Remember, order of operation matters though. So 10 divided by 2 gives me 5, because that's inside the parentheses. And then 5 squared is 5 times 5, or 25. All right. Same thing here. Let's check this one out. This one's a negative 6, though, because remember it was plus b. So this is negative 6. Negative 6 divided by 2 squared. Well, negative 6 divided by 2 is negative 3. Squared gives me 9. part C. Why don't you guys try part C on your own, and then we'll do it together in a second. All right, so we'll take our C value, divide it by 2, and then square it, which is going to give me 4 squared, which gives me 16. Just like in this example. So I took my 8, I halved it and then squared it, and I got 16. I took my -6, I halved it and then I squared it, and I got 9, just like I thought I should. And I took my 10, halved it and squared it, and I got 25. All right, so in each one of these cases it works. So this is going to be the relationship we're working with all day today, and we'll see in the next example, and the example after that, exactly why we care about that. All right, why don't you pause the video if you have to, copy stuff down, and then move on to the next one. All right. Exercise number 4 says, each of the following trinomials is a perfect square. Write it in factored or perfect square form. So what he's telling you is right off the bat, these are perfect squares. But what I want to do is I want to show that the relationship we worked with before actually works. So remember, I said if we take our B term, have it, and square it, we should get to our C term. So let's check that here. So if we take our B term, have it, and square it, we're going to get 20 divided by 2, which gives me 10 squared, which gives me 100. Right? So it works, right? I took my B term, divided by 2, and squared it. I got 100. And now what that tells me is, if this works, it tells me that when I write this as in a factored form, when I factor it, I'm going to get a perfect square. So let's do that. So let's factor this. So we want to see what multiplies to 100, adds to 20. So these two terms are going to be x, and multiplies to 100, it's going to give me 10 and 10, right? Because they both add to 20. But now if we do x plus 10 times x plus 10, that's just x plus 10 squared. Right? It's not that bad. All right, and what I want to do is I just want to show you quick that we can check our work. We can check to make sure we're right and see if we get back to where we started. So this gives me x plus 10 times x plus 10. Distributing, I get x squared plus 10x plus 10x plus 100. Combining like terms, I get x squared plus 20x plus 100. So I get back to where I started. So it works. All right. So let's try the next one. All right. In part B, I have x squared minus 6x plus 9. Let's just make sure this relationship works, and then see if we can factor it. So I'm going to take my b term, -6, and divide it by 2, and then square it, which gives me -3 squared, which gives me +9. Right? So my b term halved and squared gives me this term, the c term. So now I should be able to factor it and get a perfect square. Or when I factor it, I should get a perfect square, rather. So let's factor this. What multiplies to +9 and adds to -6? Well, it's -3 and -3, which is x minus 3 squared. Now, why don't you guys check to make sure the relationship holds true here, and then factor it. So pause the video now. All right, now let's go through it together. So if I take my b term, which is 2, and divide it by 2 and then square it, that gives me 1 squared, or 1. And now, when I factor it, I should get a perfect square. Or that tells me when I factor it, I should get a perfect square. Sorry, excuse me. When I factor x, I'm going to multiply to 1, add to 2, which gives me x plus 1, and x plus 1, and which is a perfect square, which is x plus 1 squared. So each one of these can be written as a perfect square. So I'll give you guys a couple seconds to copy this down, and then we'll work on the next one, the next exercise. All right, exercise number 5. It says the quadratic y is equal to x squared minus 4x minus 1 is shown in the graph below. So that's this guy. That's x squared minus 4x minus 1. And part A says consider the binomial x squared minus 4x. What should you need to add to create a perfect square trinomial? So we want to make a perfect square, which means we want to have that relationship hold true. We want the b term when halved and squared to be equal to the c term. So what do we need to add? So let's see. B is going to be negative 4, and they want to know what does c have to be. So let's find out. I'll take my negative 4, halve it, then square it, which gives me negative 2 squared, which gives me 4. So c has to be 4. So for me to have a perfect square trinomial, I'm going to have to add 4 to this equation. All right, so let's write that. So I need to add 4. I need to add 4 to create a perfect square trinomial. So to create a perfect square trinomial. All right. In order to add 0 to the binomial, x squared minus 4x, so in order to add 0 to this, what should we subtract given part A? So what this is asking is, now let's look at the new, let's go back and let's look at the new equation we just made, or the new expression we just made. The expression is going to be x squared minus 4x plus 4. Okay. So what I just did was I added 4. But can I ever just add 4 to an expression or equation? No, right? I really can only add 0. So it's asking me what can I add, or what can I subtract now to make it so I add 0? Well, if I subtract 4, then what did I technically just add? I just added 0, right? So that's what it's asking me. What do I have to subtract? And the answer is, well, if I subtract the c value, if I add and then subtract the c value, I really just added 0, right? So I need to subtract this, so I need to subtract the c value, or 4 in this case. So I need to subtract the c value, or 4. Now, this isn't actually completing the square yet, but let's see the whole method in total, right? So let's walk through it now. What I'm going to do is, so part C is asking me, use the method of completing the square. So using completing the square, now rewrite the trinomial x squared minus 4x minus 1 in an equivalent shifted form. According to this form, what's the vertex? And then verify it by looking at my graph. So if I look at my original equation, it gave me x squared minus 4x. And what I'm going to do is I'm going to give myself some space and then put the minus 1, that last term. Because what that lets me do is it lets me now fill in my c values. Well, I said if I add 4, this right here is a perfect square. Right? But I can't just do that. I can't just add 4 to my expression. I have to subtract 4 as well. Now I didn't change anything, right? So this perfect square, you guys can factor that, right? When I do, I get x minus 2 times x minus 2. I'll put the minus 4, minus 1 here. Combining these two, I get minus 5. This gives me x minus 2 squared. But if you guys remember, vertex form, or shifted form, terrible. Vertex or shifted form is y is equal to x minus h squared plus k, where the vertex is h comma k. So looking at this, my vertex then is 2, -5. All right. So that's the vertex, because that was what the question was asking. But then it says verify it by examining the graph. So let's look at the graph for 2, -5. Well, 2, -5 is this lowest point of my parabola, which is also known as my vertex. So I'm done. I got the right answer. All right. Sorry. Why don't you guys spend a second, copy it down, and then we'll move on to the next one. So before we go to another question, I just want to go through the process of completing the square one more time. So for the quadratic, y is equal to x squared plus bx plus c. So that's any quadratic. No, a equals 1, so this term right here equals 1. To complete the square, I have to take my b term, I have to divide it by 2, square it, and then add or subtract it. So just like we saw before. All right, so now let's try a bunch of examples. All right, guys, and now let's do a couple of practice examples. In exercise 6, it says, write each quadratic in vertex form by completing the square. Then identify the quadratic's turning point. The last two problems involve some fractions, but we're going to stick with it. I know you guys can do it. All right. Exercise A says, y is equal to x squared plus 6x minus 2. And they just want me to complete the square and find the vertex. So, completing the square, I'm going to say y is equal to x squared plus 6x. I'm going to give myself a little bit of space and write the minus 2. All right. Now I have to find this c term. To find the c term, remember, I'm going to take my b term, divide it by 2, and square it, which will give me 3 squared, or 9. So I'm going to add 9 and subtract 9. All right. Remember to group these guys together, because when we group these, when we factor this group right here, we're going to get a perfect square. And then we'll be left with some stuff on the outside. So let's factor. When we factor this, I'm looking for something that multiplies to 9 and adds to 6, or 3 and 3, right? X plus 3 times x plus 3, minus 11, which gives me x plus 3 squared minus 11. Now finding the vertex or the turning point, that's going to be -3, -11. Remember -3 because it's a positive and it's supposed to be a negative. So minus a -3 will give me will give me -3. All right, part B. Part B says x squared minus 2x plus 11. So let's separate that like we write the others, or like we've done the others. I'll put my plus 11 here, and I'll find my c term. So I'm going to take my b, divide by 2 and square it, which will give me minus 1 squared, or 1. Grouping these together, this is what I want to factor. So this will be x minus 1 times x minus 1. And then combining these, I'll get 10. Well, this is x minus 1 times x minus 1, or x minus 1 squared, plus 10. And I can find the turning point pretty easily. The turning point would be 1, 10. All right. So now what I'm going to do is I'm going to ask you guys to pause the video and try this one on your own. And then we'll go through it together in a second. So why don't you pause now? All right. So rewriting this, I get y is equal to x squared minus 10x plus 27. Finding my c term, I'm going to take the negative 10 divided by 2 and square it, which will be negative 5 squared, or 25. So remember, I'm adding the term inside the grouping and subtracting on the outside. And this will give me a perfect square. This will be x minus 5 times x minus 5. When I add these two together, I'll get plus 2, which will give me x minus 5 squared plus 2. Well, finding the turning point. The turning point will be 5 comma. All right. 3 more. We're halfway done. So this next one, I'm going to have you guys try it on your own. But I want you guys to think, what's different about this question? And is there really anything different? So pause the video, think about it, and then we'll just do it on our own. Or we'll do it together, sorry. All right. So in this question, there really isn't anything different. And if it helps, you can even put a plus 0 here. Right? So when we write this one out again, we're going to get y is equal to x squared plus 8x. I'm going to leave myself a little bit of room, and then I could put the plus 0 here. I'm not even going to bother with that because it's not going to change anything. Adding 0 doesn't change anything. So if I rewrite this, or if I find my c term, I take my 8, divide by 2, and square it. And then I'll get 4 squared, or 16. So I'll add my 16 and group these guys together. But I can't forget to subtract the 16. Now when I factor this, I'll get x plus 4 times x plus 4 minus 16, which will give me x plus 4 squared minus 16. All right. And then the turning point becomes negative 4, negative 16. All right. 2 more. Now the last 2, it says in the directions, are going to involve fractions. So let's be careful. We're going to work through these pretty slow, and we'll work through the first one together. All right. So example E. Example E says y is equal to, x squared. Oops. Plus 5x. And give myself some space and put a plus 4. All right. So when I'm trying to complete the square here, I'm going to take my 5 and I'm going to divide it by 2 and square it. Well, when I divide 5 by 2, it doesn't give me a whole number. So I don't want to write a decimal. That'd just be a mess. So what I'm going to do is I'm going to write it out. I'll get 5 halves times 5 halves. Well, when I multiply fractions, I multiply across, remember? Multiply the numerators and then the denominators, which will give me 25 over 4. Well, if I add 25 over 4 then, and subtract 25 over 4, I can factor this, and this will give me a perfect square, believe it or not. Well, let's think to ourselves, what 2 terms multiply to 25 over 4, but add to 5? I'll give you a hint. They're right here. 5 halves times 5 halves gives me the 25 over 4. And 5 halves plus 5 halves, well, that's 10 halves, right? Or just 5. So this is really x plus 5 halves times x plus 5 halves. And now I want to combine these two, right? Well, if you guys remember, this is 4 over 1. So if I multiply this one by 4 over 4, we'll have the same denominator, right? So I'll get minus 25 over 4 plus 16 over 4. When I combine everything now, I'll get x plus 5 halves squared minus 9 over 4. So the turning point The turning point then is 5 halves, negative, right? Because this is a positive, so it's minus negative 5 halves, minus 9 fourths. A little bit messy, but not that bad, not that much different than any of the other work, right? Right. So now I'm going to give you guys a second. I want you guys to try this last one on your own, and then we'll do it together. So pause the video. All right, so let's do this one together. If I rewrite my question, I get y is equal to x squared minus 9x. I just give myself some space and put a minus 2. All right. Now I'm going to take my 9 halves, or my 9 and divide it by 2, and square it. So 9 halves squared. Well, this will be negative 9 over 2 times negative 9 over 2, or positive 81 over 4. So I'll add 81 over 4, subtract 81 over 4, and get all this stuff in parentheses. So just like the last one, well, I want to find two things that multiply to 81 over 4 and add to negative 9. Once again, they're right here. So this will give me x plus, or I'm sorry, x minus, right? X minus 9 halves, and x minus 9 halves. Oh, but I want to combine these two. So this is 2 over 1. I'll multiply by 4 over 4 again. Minus 81 over 4. 81 over 4. Minus 8 over 4. One more step and I'm done. Write everything out pretty. X minus 9 halves squared minus 89 over 4. Finding the turning point. I get 9 halves, negative 81 over 4. A little bit messy, but not that bad. All right, so that was it, guys. That's completing the square in a nutshell. I'll give you guys a couple of seconds to copy this down if you haven't gotten it, and then I'll erase it. All right, and that's it. So I hope you guys enjoyed this lesson, and I hope you guys keep watching our videos, and I hope you have a great day. Thanks for watching.